In this video, I'm going to explain VBA data types and why it matters, why we need to think about which data types to choose when we are working in VBA. Spreadsheets adapt to us dynamically, and they're made to be flexible on purpose. So I typed an integer in here, and it took it. I typed a real number in here, and it took it. And then the product of those two is a real number as well. So it's not making me specify by calling out a different data type that's going to limit what's stored in these things. And so we're used to that. But when we work in a programming language, it's good if we are more precise, because the programming language can help us use the resources, the computing resources efficiently, and it can also help us not make mental errors or little logical mistakes. Let's look at some of the data types that we can use in the Visual Basic for Application language. Up here in beige, we have integers and long integers. These are whole numbers that have no digits to the right of a decimal, so they're just whole numbers. And then down here we have real numbers that you can have things to the right of a decimal point. And you can see that as we move down, we get bigger and bigger numbers. So for example, let's look at the integer and the long integer. For an integer, it can be plus or minus 32,000, and it uses 2 bytes of memory. For a long integer, you can store a much bigger value, plus or minus 2 billion. So that's for a larger integer. And if you need to store things to the right of the decimal place, then you could use one of these. And these are for different purposes. A currency will let you store plus or minus 922 trillion, so that's a big number. And it will only let you store 4 digits to the right of the decimal point. Things for currency, usually that's enough. It's really designed to store dollar values. If you need to do in scientific work, though, 4 digits would not be enough after the decimal point. And so VBA also has single and double real numbers in there, which allows you to have 45 digits or 308 digits respectively. And some of those digits can be to the left of the decimal and some can be to the right. So you can store large numbers in a single and very, very large numbers in a double. So these are really used primarily for scientific programming, for things where you don't want to round off because you're doing very precise calculations. And so that's why you would use like a single and a double data type. A date data type allows you to put in dates, and a Boolean data type allows you to put in true or false values. A string data type allows you to put in alphanumeric values, and there's 1 byte used per character, so the longer the string is, the more bytes are used. And then a variant, as the name sort of signifies, it's very much like Excel is interactively. That is, it just automatically adapts to whatever you put in there. That's good and bad. The good part is that it's very flexible. The bad part is that it slows your processing down, because Excel spends time trying to figure out what kind of data might be stored in there based on what you're throwing at it. And it has to make educated guesses about what types of things to store in that sort of data type. So we use variance sparingly. We only use it when it makes sense. Let's take this simple example of an invoice where we just have a customer name and some quantity price and the extension amount, and let's do some things. Look at an example how this would work in simple VBA code. So in this case, it actually made sense to have a quantity that I declared as integer, because there are no partial numbers in here. There's nothing to the right of the decimal, and then I didn't need more than 4 digits to the right of the decimal place, so I was able to use currency for both of these. You can see that I have a formula in here that just multiplies the quantity times the price, gives the extension. This program would run and there wouldn't be any real problems. Let's go look at an example. But my program, and this shows the value in the locals window, you can see the program would come up with things that as it should. Now let's show what happens when we do some things that break it, that do not make sense. Let's say, for example, that we were to try to put a bigger value than 30,000. Let's put in 35,000, which is, it's going to be more than can be stored in a single integer. So now, even though we haven't changed anything about the code, by putting a value in that's too big, when we go up and run the code again, it should throw an error. Because what happens is, we tried to put a value bigger than 32,000 in here, and it says that's an overflow error. That's showing us that we're making a mistake. Now let's do another sort of thing here. Another way we can get an overflow error is by taking something that's within the size of what an integer can store and then getting a product. If we find currency as integer, we're also going to throw an overflow error because it's too big. This is bigger than 32,000, so that is a problem. Okay, so that's one way where it's easy to kind of get them and not see them coming is to size the variable correctly for one cell and then not realize that when that cell is multiplied by something else, it might be bigger. Another type of error is if we take something like text and try to load it into a number. So if I, instead of taking what's in B2, I take what's B1 and try to put it into an integer, then it'll throw a data type error. I get a type mismatch where it's saying, I didn't expect an alphanumeric string to be put into a numeric variable. Now, another common error that shows up when we don't think about our data types carefully is truncation or rounding errors. So right now, this value is $1.55, and it can easily be stored in the currency data type. But what if I go back and change that to an integer? Well, integers cannot store anything to the right of the decimal point. So what happens, 1.55 is rounded to the nearest whole value, the nearest integer value, which is 2. It didn't throw an error, but it is an error because what's happening is when it rounds from $1.55 to 2, this is going to end up being 64,000 instead of 49,000, and Sally would not be happy if we're doing math that way on what we charge her. So those are some examples of data type related errors that you can get into and why it matters and that you should use them logically and specifically.